Welcome grade 11s and making some nice videos here that will hopefully be helpful, but use the pause button effectively. So as you get a bit of information, go, okay, I don't need any more help, and you carry on by yourself. And then if you don't need any more of the video, close it. Don't just watch through for the sake of it. Other thing is, obviously make sure you got your diagrams in front of you so you're scribbling on them and doing it. The idea is not just to watch the video, nod your head and go, okay, that's how you do it. You've got to be writing these things down as you go. Okay, so with that said, let's jump into it. In triangle ABC, we're told that AB equals AC. Okay, so AB equals AC. Okay, so in this triangle over here, it's an isosceles triangle. So already we're seeing something. So I start jotting down in my diagram, those two angles are going to be equal. So if I know one of them, I know the other. Isosceles triangle already, that's a lot of information we've been given so far. A1 equals 36 degrees. Okay, well, there's 36. So before reading any more information, we can work out what C2 is and what B1 and 2 are, because it's an isosceles triangle. So let's grab our calculator out and do that. I've got a calculator here somewhere. Oh, look at that one. I'll use that one. So I can go 180 divided by, or minus 36, and divide that by 2. And I know that that whole angle is 72, and that whole angle is 72. But wait, we've made a statement, so let's capture that. So that first angle, CBA, I can't just call it B because I don't know which angle B it is equal to C2 is 72 degrees, and that's because we saw that it was an isosceles triangle and we're already given A1. Okay, cool. So we've captured that bit of information and we kind of used those things. Okay, CD is parallel to BD. So let's just see what part of the diagram that is. This one should do us, right? So it says that CD, that's this one over here, is parallel to BA. Okay, well, that means we can do things like, oh, there's an alternate angle already happening. So from that, C1 must be 36. I don't know if we'll need it. And there's always this balance of, do you start scribbling on the diagram, everything, and jotting down before we know where we're going? Or do you look what the question's actually asking? I think it's somewhere in between. I think it's probably worthwhile reading through. But in this case, there's something that I've seen that's going to be so easy to jot down that C1, oh, let's jot that down firmly. C1 is equal to, what did we say? It is 36 degrees because of those parallel lines. So we've got alternate angles on parallel lines. Okay, cool. Well, that may or may not be useful. And as I said, it'd probably be wiser to have read through the full question rather than just putting these down. Okay, so it says, and BD bisects B. Okay, so what's hidden in that bit of information? We're told that BD bisects, that means that B1 is equal to B2. Okay, well, we already worked out what they were. And if we're given that information, it's probably going to be useful somewhere. So we can just go B1 equals B2 equals 36 degrees. And we're pretty much given that it bisects. So I'm just going to put given, or we might not even have to have a reason. Maybe given that it bisects. That captures our thinking nicely. So that's 36 and that's 36. Okay, cool. Now what do we actually have to do? Prove that quadrilateral ABCD is cyclic. Okay, so to prove that something is a cyclic quadrilateral, let's get rid of this we don't need for now. We just need to show one of three things. We could show that angles in the same seg are equal, because if they're equal, then it's a cyclic quadrilateral. So let's have a look. Let's capture some angles in same seg. So I'm going to get these out so I can see. If, say, we started from, let me go from here. If we started from B and C, we could create that angle. And starting from B and C, we could also create that angle. So if we could show that A1 equals D2, then cyclic quad. Okay, well, that looks like it's still going to require a bit of work. So let's see, because I think we've probably got enough information. Let's start from A and D. So from A and D, let's get this one out and say, well, we could create or subtend that angle there. Hey, well, it's 36. We already showed that. And we could also create or subtend this angle here at C1. Well, those two are equal. We already showed it. So therefore, this is a cyclic quadrilateral. So let's capture that down, because we're actually done. Well, that made life a lot easier. All our hard work was worth it. So we can say that ABCD is cyclic quadrilateral. And our reason for that is that we've shown these angles in the same seg were equal. But our reason can't be angles in same seg, because that would imply that we already knew it was a cyclic quadrilateral. So we're going to use this keyword, and that is converse. Converse angles in same seg. In other words, because the angles in the same segment are equal, it is a cyclic quad. Okay, so that wasn't too bad. This first video was a bit longer because I wanted to explain a few things. We'll get some momentum going in the next one. I'll see you in the next one.